Hello, YouTube watchers. This is another installment. My name is Dean, and we're looking at digit degree, a Codewars exercise done in Python, or it will be done in Python. So it hasn't been done yet. Although, yeah, I did do it before, but I'm going to do it now here live for you. And now that that unnecessary introduction is out the way, let's dive in. Let's define a digit degree of some positive integer as the number of times we need to replace this number with the sum of its digits until we get to a one-digit number. So we're going to be given an integer n, and we need to get the sum of its digits until it is a one-digit number. And we're going to count each time, and that will be the degree. Got that? I know you do. But let's look at examples. For n equals 5, the output is 0. Now why is it 0? Because 5 is already a one-digit number, so you don't have to go through the operation. The operation here is going to be, if you have a multi-digit number, we're going to get the sum of the digits until, over and over, until it's a one-digit number, and that will be the end of the operation. If we look at n equals 100, the output would be 1, because it only takes one summing to get it to a one-digit number, because we got 1 plus 0 plus 0, that equals 1, and that is a one-digit number. Looking at n equals 91, the output will be 2. It's going to take two operations to get it to a one-digit number. So 9, you say 9, are you right? 9 plus 1, that is a 10. And we see 10 is it is a two-digit number. So then we do 1 plus 0. I don't know why I'm saying 0 like that. And that equals 1, and there's your one-digit number. This was two operations, 1, 2. So that's why we get a 2. So you see it now, you understand it, you got it crystal clear. Clarity is power, where we're going to start with a number, and we're going to sum the digits of the number until we get it down to a one-digit number, and every time we do a summing of the digits, we're going to increase a count. That count will be the degree. And that rhymes. Got a rap verse there. Outstanding. Let's dig into the code here. Digit degree. I always say let's dig into the code, but there's no code. I actually just write the code from scratch. Yeah, hopefully y'all can see this okay. I can see it, and that definitely counts. Digress, degree. Degree is going to be an integer, of course, that will hold my count of the operations. So because we're doing something over and over again, potentially, we're going to need a loop. And the while loop is well suited for this, because in the while loop in Python, you can really customize your condition. If you want a customized Boolean expression as your condition, you need to use the while loop. There's a little basic guidance there. So because the solution will be when the number is one digit, I'm going to make that really the condition of the loop. While the number is not a single digit, we will keep looping. And putting that into code is like this, where n is going to be an integer, and you can't get the length of an integer, I guess, in a condensed format. So I'm going to turn the number into a string temporarily and get its length, which will be the number of digits. So I get the length, and while the length is not equal to 1, meaning while the number of digits is not equal to 1, I'm going to keep looping. And what I'm going to do in the loop is I'm going to do the operation of summing the digits. You sum the digits, and then you use that result to replace n with a new value. Then you loop around and do the test again. So the loop is going to be add the digits together, get the sum, loop around. Well, actually, it's add the digits to get the sum, use that result to replace the previous number, then you loop around and check if the number of digits is equal to 1. So I will do that now, and I'm going to do a lot of that in one line as per being pythonic. Yeah. And I'll break this down soon, but I'm going to type it first. A lot going on, but yeah, you can do this kind of stuff in Python. My guideline when I teach people, when you're looking at a semi-complicated expression, is to start from the inside out. Really, what this line is going to do is it's going to separate the number into digits, convert to integer, and then sum the digits. That's an abbreviated explanation. A real solid explanation is going to be, I'm going to first convert my integer to a string, then convert that string to a list so the digits are separated. But when it's a list, the elements will be strings, so I can't do a summation of that. So then I use the map function to convert. I use the map function to convert each string, each individual numeric string, into an integer. And then I've got a list of integers, or really a map object of integers, and I will sum that object, getting my sum and then putting it into n, which will be n's new value. And then it'll loop around and check it for being 1 digit. So there's your breakdown, folks. And every time I do that, I'm going to increase degree by 1 because I have done an operation. So I need to record the new degree. Once this is done, I return degree because once I get out of the loop, n will be 1 digit, and I've done my set of operations. So it is time to go. And now it is time to run. That one passes the basic tests. And looking at here, the more comprehensive tests pass. Very good, very good. I did an amazing job on this, folks. If I did say so myself, whatever. All right, this is it. What it is a digit degree, a Codewars exercise in Python. My name is, you see it on the channel, my name's Dean, and I'll do another one pretty soon. But for now, I am out.